as we've just seen, whenever we run our program, all we get is this rastering note spinning in a circle, and basically the web browser is waiting for information in the form of images to display to the screen. Now, what we're going to do is show you what will happen once you're totally done to get a sense of where you're going to ultimately go. There's two ways you could do this. One is if you want to try it out on your own. Oops, wrong one. If you want to try this out on your own, you can go to, we have a Heroku version of Bearmaps deployed to the web, which you'll also be able to do with your code. And this link, you can try and type it in from the screen, but it may change. And I'll make sure that it's up to date in the spec as time goes by. And it'll allow you to scroll around. Now, it's going to be pretty slow because it has to run on a free computer that we're using at Heroku. So I'm actually just going to run it locally. So to do that, I'm going to switch from the skeleton file to this is now a solved version of Bearmaps. So when I run this server this time, and then I go down and I open the map.html file, you'll see something quite different happens. Instead of just giving us a spinning rastering message, it will complete the rastering. And I have here a map of part of Berkeley. Now I can scroll along, and as you do this, what will happen is your web browser will start making different requests to your Java program, and your Java program will need to find the appropriate images and feed them. Now, there's a little bit of glitchiness to the front end. This is not an industrial strength application, and you'll find that the zoom buttons are particularly strange. Like, you'll see little jumping things happen, and that's not because your program is wrong, by the way. It's just, sorry that our front end is not amazing, but I hope it's good enough. So that's one thing you could do, is pan around and explore Berkeley and its environment. You can also, though, instead of just scrolling along on the map, you can get routes. So if I double-click in one location, and then I double-click somewhere else, I will get a route from point A to point B. Now in Homework 4, you may remember that when you wrote A star, it would give you a path if you ran the street map demo, where it would say to get from, say, vertex 262,000 to vertex 888,000 or whatever, it would say go from some number to some number to some number to some number to some number, and so forth. Now in this case, it's actually meaningful to us because we're going to overlay, using lines, the paths between all those vertices. So in this case, we end up getting driving directions or walking directions, or however you want to get from point A to point B. Now you'll notice something a little funny about the direction that we get is that it is doing lots of turning. This is not how you would give directions in the real world, and that's because it's trying to minimize the total length of street covered. And so that's not going to be the most efficient route, but that's because, taking turns takes time. But if we're only minimizing distance, these are the kind of driving routes you would get. So this project's actually interesting from the perspective of, if you're wondering, how do I minimize the distance, not the time? What would that look like? Well, you are going to write the code to do that. So you can, also clear the route. So after I create a route, I can hit clear route. I can scroll somewhere else, and I can click here and click here. And that might seem a little silly that you would do this clear route thing, but it's just something we did so that if you want to experiment with the code, there's actually a piece of code that handles the clear out button, and you can try and make it do other stuff if you want. Next thing we could do is this code also supports an autocomplete feature, and this is now going beyond the capabilities of Google Maps. So for example, I can type in and I can do like a T, yeah, there we go, top dog. So I press enter, it does an autocomplete search, and it finds some top dogs. There's one, and there's one. Now this is very bare bones functionality. All it did is make little red circles, but hey, it works. You can also type in, for example, I don't know if Soda Hall's in this thing or not. I guess not. Okay, let's do, I don't know, let's name a place. McDonald's. People like that place. Yeah. Where is it? McDonald's? There it is. Okay. So again, very basic piece of functionality, but we're just trying to demonstrate that. And you can see here I have some print statements that are showing off what's going on. Okay, and last feature that I wanted to show off is that, so basically part 1 of the assignment is just getting the map to show up. Part 2 is getting the routes to draw. And then part 3 is this autocomplete feature. Now if you really want, you can go extra above and beyond, and you can find routes that are not just text. Find routes that are not just text, but which also involve written directions. So that will be the final part of the project, and that's optional. And so in this case, it gives you these directions saying start on Lincoln, then go to McGee, Virginia, Grant, and so forth. All right. So that's the whole story in terms of what you're going to build. And so in the coming video, I'll give some tips about how to get started, how to actually implement this, but now hopefully you have a clear idea of what the project does. Now again, if you want, you could try using our web deployed version, though I will warn you in advance, it may be very slow, especially if a lot of people are using it. All right, see you in the next video.